everyone, once again, this is Sir O, your teacher in this session. If you are new to this classroom, I will really appreciate it very much if you can subscribe to my channel, and please do consider clicking that notification bell for you to be updated with my next session. So today you are going to learn how to solve quadratic inequalities. Now in our previous session, we did define quadratic inequality as an inequality that contains a polynomial of degree 2 and can be written in any of the following, where a, b, and c are real numbers and this a should not be equal to 0. And of course, in quadratic inequality, we will be using the inequality symbols. Now, before we can solve quadratic inequality, let us consider first the suggested steps that are being used in this tutorial. So these are actually the steps. You may or you may not follow this one, but once again, I would like to remind you, this will actually guide us in solving quadratic inequalities. So let's start with example number 1. We are asked to solve this quadratic inequality p squared minus 2p minus 3 is less than 0. The very first step that you are going to do in solving quadratic inequalities is to write the corresponding quadratic equation of this inequality. That is, p squared minus 2p minus 3 is equal to 0. Now, since this is written in the standard form of quadratic equation, we are now ready to factor this out. Of course, the factors are p minus 3, p plus 1 is equal to 0. Why? Because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2 because these are unlike sign. So what we are going to do in this factor is we equate them to 0, and simplifying this one, that would give us p equals 3 and p is negative 1. Now, these values are very important because this will serve us to divide the number line into 3 regions. Region A are the points that exist at the left side of negative 1. Region B will be the points that exist between negative 1 and 3. And region C are actually the points that exist at the right side of 3. Now, why I explain this to you? Because those points actually serve as our basis for test point. Because you will create a test point table, and the parts are the region, the test point, the given quadratic inequalities, and of course, the result. Now, under region, of course, that is region A, B, and C. And now, let's go to the test point. Of course, we will choose a number, any number, at the left side of negative 1. You are free to choose any number. So in this tutorial, I'll choose negative 2 because negative 2 is at the left side of negative 1, which is in region A. So what will you do with this test point? This test point is actually to be used in substituting the values for p. So that is, of course, 4 because negative 2 squared is 4. Negative 2 times negative 2 is 4. Copy negative 3 less than 0. 4 plus 4 minus 3, of course, that is 5 less than 0. In this statement, 5 is less than 0. That is false because 5 should be greater than 0. So let's go to region B. If we choose 0, because 0 exists in between negative 1 and 3. Substituting that, of course, that will give us negative 3 is less than 0. So this statement is true. Now let us choose a number as a test point for region C. That is example 4. Substituting that one, of course, that will give us 5 is less than 0. This statement is, of course, false. Now let's continue. Now going back to our number line, Since the given quadratic inequality uses less than, in other words, negative 1 and 3 is not included in the solution. That is why I used unshaded circle, because this would give you an idea that negative 1 and 3 is not included in the solution. Now, since in our test point table, the only true statement is at region B. In other words, the solution set exists on the points between negative 1 and 3. That is our solution set. Now, let us choose a number in between negative 1 and 3 for us to check if this is really the solution set. Let's say P is equal to 1. Substituting P is equal to 1 to the original inequality as given, of course, that is, and replacing that 1 with 1, that will give us negative 4 is less than 0, which is true. Therefore, P such that P is greater than negative 1 and P is less than 3. So this will show to you that these are the points that exist between negative 1 and 3. Or you can write your solution set like this: P such that P is greater than negative 1, but P is less than 3. But if the question is asking you for an interval notation, so we'll make use of an open and close parenthesis, because this is an open interval based on the given inequality that we used less than. Okay? So if you have some questions, you can always write your question in the comment section. I will be happy to answer them. Question number 2. X squared plus x minus 2 is greater than or equal to 0. So the very first thing that you're going to do is you write the corresponding quadratic equation by replacing the inequality symbol by an equality symbol. Since this is already in the standard form of quadratic equation, we can actually factor this as x plus 2, x minus 1 equals 0. Because 2 times negative 1 is negative 2, and 2 minus 1 is positive 1, which is imaginary. What we are going to do with this factor is that we equate them both to 0, and simplifying them, that will give us x is equal to negative 2 and x is equal to 1. These values will be used to divide our number line, which is the negative 2 and 1. So the points that exist in every region, we will make use that one in our test point table, of course making use of our given quadratic inequality, and of course our regions A, B, and C. We will choose a test point that exists at region A, shall we say negative 3, and substituting that one in a quadratic inequalities and simplifying them, of course that would give us 4 is greater than or equal to 0. So this statement is actually true. So let us choose a point in region B, shall we say 0, substituting that one, that will give us a statement which is negative 2 greater than or equal to 0. Of course, that is false. And in region C, let us say 2, and substituting that one, that would give us 4 is greater than or equal to 0. That is a true statement. Of course, let us continue going back to our number line. Now, let us analyze our given quadratic inequality. Now, since the inequality symbol is greater than or equal, so therefore, negative 2 and 1 are part or included in our solution. So, negative 2 and 1 are included. That is why I make use of a shaded circle. Now, since in our test point table, the true statements are region A and region C, so therefore the solution exists at this region. Now, after this, what we are going to do is we choose first a point that exists at point A, or region A rather, and a point at region C. If it is a true statement, then that is now our solution set. So let us say x is equal to 2. That is a point at region C, which is at the right of 1. So that gives us a true statement. So next, say x is equal to negative 3, which is at the left side of negative 2. So that gives us also a true statement. Therefore, our solution set x such that x is less than or equal to negative 2, because the value of x should be less than negative 2 or equal to negative 2. And x should be greater than or equal to 1. So 1 is included in the solution set and all the points that exist at the right side of 1. Question number 3. 2m squared minus 5m is less than or equal to 3. So if you notice, this is not yet written in the standard form of quadratic inequalities. What we are going to do is we transpose first 3 to the other side of the inequality, which gives us 2m squared minus 5m minus 3 is less than or equal to 0. So we are now ready to write this one in the corresponding quadratic equation, that is 2m squared minus 5m minus 3 equals 0. And factoring this out, that gives us factors of 2m plus 1, m minus 3 equals 0. Equating them both to 0 and simplifying them, we have m is equal to negative 1/2 and m is equal to 3. And now we are ready to divide our number line into 3 regions using negative 1/2 and 3. So in our test point table, of course, making use of our given quadratic inequality, and of course with our region, let us now choose a test point in A, which is negative 1, because that is at the left side of negative 1/2. Substituting this to our given quadratic inequality, of course that would give us 4 is less than or equal to 0 is a false statement. In region B, the test point, let us make use of 0. Substituting that one, that gives us negative 3 is less than or equal to 0 is a true statement. And in region C, let us use the test point of 4. Of course, that would give us 9 is less than or equal to 0 is a false statement. Now, let us continue and going back to our number line. Now, since what is being used in our given quadratic inequality is less than or equal, so therefore, negative 1/2 and 3 are included in the solution set. Since in our test point table, the only true is at region B, so therefore, all points that exist in between negative 1/2 and 3, so in other words, that would be our solution set. So let us choose a point in between negative 1/2 and 3 for us to prove that the solution set is true. So let's say m is equal to 2. So if you notice, negative 5 is less than or equal to 0, that proves to us that all the points that exist at negative 1/2 and 3 are the solution set of the given quadratic inequalities. Therefore, our solution set, m such that m should be greater than or equal to negative 1/2, and m should be less than or equal to 3. This will show, guys, that the solution is from negative 1/2 to positive 3. Or you may write this one this way, m such that m is greater than or equal to negative 1/2 and m is less than or equal to 3. And of course, if the question asking for an interval notation, so we'll make use of bracket because negative 1/2 and 3 is included in the solution. That is why close bracket, open and close bracket, negative 1/2 and 3 for our interval notation. Now, if you like our presentation, I hope you can give a like and share this to others. And please do consider subscribing to my channel. That would really help me a lot and I will really do appreciate it. And please click that notification bell for you to be updated with my next session. Thank you so much.